So I guess students are joining and there are just few students. So let's wait for more 5 minutes and we shall start the boot camp at 4 5 p.m. Okay. Um, Hello everyone, once again, and I am Ahad Shaikh from Elite Techno Groups. I work as an electric vehicle research associate, and I warmly welcome you all to this bootcamp. So let me present my screen and uh, just let me know if it's visible at your end. Okay. Mhm. Is my screen visible? Yes. Okay. So today's topic is how to break acceleration world records, and the answer to this is a electric motor. So in today's session, let's see what exactly we will be having in today's session. So firstly, we will talk about basics of electric motor, what exactly it is, then how does it work, then different types of electric motors which are out there and have various applications. Then we will talk about various motors which are used in particularly electric vehicle applications, and what are the mounting positions of EVs and how it varies, and what are the advantages and disadvantages of having different ways of mounting motors in electric vehicle. Then we will specifically talk about the hub or in wheel motors, and lastly we will see the acceleration records that electric vehicles has set using electric motors. Okay. So first of all, I would like to I want you guys to be more interactive during the session, and let's have a few discussions on some topics if I mention, and in between you guys can unmute yourself, ask questions if you have any, or if you want to discuss something, so that also can be done during the session. Okay, so feel free to unmute yourself and ask questions. Yes. So starting with the first question, what is an electric motor? So as we all have studied in our lower standards, electric motor is a device that converts electrical energy into the mechanical energy. So what happens? We provide the electrical energy, and what exactly electrical energy is nothing but the current and voltage. So that thing we give as an input to the motor, and something happens inside it. It has few components, some conversion happens, and what we get from the out of the motor is a mechanical energy, and that energy is in a form of rotary motion. Okay. So like there is a solenoid as well, if you are familiar, that when we feed electrical energy to solenoid, it also converts it to the mechanical energy in the form of back and forth motion. So but electric motor, what specifically it does is it converts it into a rotary motion, and we all have a very wide applications of electric motors in our day-to-day life. Apart from electric vehicles, whether it's fan, washing machine, or any like major electrical appliances, we have electric motors. So these are very great inventions of engineers, and today we will be talking about its application in electric vehicle only. So firstly, let's see how exactly it works. So I won't give much time to the working principle because we have lot of things to talk in terms of application of motors. So we will just quickly see how exactly it works at a very basic level. So firstly, there are permanent magnets, and there is a coil, or we can say armature. So when you pass current through this coil, whenever there is a flow of current, the magnetic field is generated. So what happens? The it generates a magnetic field which the polarity of which is similar to which is shown in image. And what happens if we put different poles of magnets, the permanent magnets which are set? So what happens? Similar poles, they repel each other, and opposite poles, they try to attract each other. So what happens? The armature tries to move to put the opposite faces in front of each other, and this is how we get the rotary motion. So when it becomes straight or very parallel to permanent magnet and armature, so there we need to change the polarity in order to get it reverse. So what needs to done, we need to change the polarity of the current. So once we change the polarity, so like in previous slide, as you see, north pole is here, south pole is here. Okay, but once we as we change the polarity, south face will come here and north face will go there, and this is how it will continue rotating. And this is how we get the rotary output out of the motor. But what challenge we have to face is we constantly have to change the polarity or the connections which are present. In order to avoid that, what solution engineers came up with is using the commutators. So these are the commutators and these are the brushes. So what happens, it constantly keeps changing the polarity of the armature, which is rotating inside the permanent magnets. So this is how, if you happen to see the animation of this particular working of motor, it will get explained in a very better manner. So in terms of image, you can understand that the power flows, electricity flows in this way, and this is the current polarity, and it will rotate. But let me show you this animation. Yes. Okay, so this is how the with the help of brushes which are present at the commutator, it constantly keeps the changing polarity, and we achieve the continuous rotation of the armature inside a motor. So this is how we exactly get the rotary motion, by providing the electricity to the motor. And there are different types of electric motors which are available. So you can see how they are categorized. So based on the input that we provide, they we can classify them. So if we are connecting them with the DC source, it will be called as DC motor, and we are connecting with the AC source, so it will be called as a AC motor. So in AC motor as well, we have various types. So initially when DC motors were developed, it was a brushed DC motors basically. And brushed DC motor had various like friction and the losses between brush and commutator. So that's why we came up with the brushless DC motors, which are very much advantageous as compared to brushed DC motor. And in terms of AC motors, there could be synchronous motors and asynchronous motors, which is also called as induction motor, which can be provided with single phase and three phase supplies. So this is a general classification of motors. And now let's talk about the different electric vehicles, which type of motors they are using. Okay, so in electric vehicles, uh, how many types of motors can be used is brushless DC motors, because brushed DC motors, it has a huge amount of losses, so that cannot be used because it won't be very much efficient to use those motors. So that's why we go for brushless DC motors. Then permanent magnet synchronous motors are there, interior permanent magnet motor. So what happens in induction motors, we insert the permanent magnets inside the rotor, so in order to get the good flux and high amount of flux, and to reduce the back EMF. So those kind of modifications have resulted in a various types of motors, and based on their characteristics and properties, those can be used in specific electric vehicle application. Okay, so let's do a small activity. Okay, so can you guys name the models which are present here on the screen? So first, let's talk about this one, left top image. Which model is this?
E-Cheetah,
Sorry.
Bajaj E-Cheetah.
Yes, Bajaj Chetak, exactly. So this is Bajaj Chetak, and what about this one? I suppose, being automotive or electric vehicle enthusiast, you should know what exactly the current models available in the market are, and what are their specifications. So you can name which all models are here if you have idea. Ampere Electric. No, that's not Ampere. So this one is Ola S1, and this is Bajaj Chetak. And what about these two? So this one is Ether 450X, and this is Simple One. So I wanted you guys to identify actually which type of motors are used in these particular two wheelers. So Bajaj Chetak and Ola S1, they uses brushless DC motors for to propel their vehicle, and Ather and Simple One, they use permanent magnet synchronous motors. So based on their drivetrain requirement, what weight, what load they carry, and the range they wanted to have, and per kilowatt hour of consumption. So considering all these factors, the suitable motor has to be decided for a particular application. Okay. And so this was just a little bit about two wheelers. So in four wheelers, if we talk about Tesla, so Tesla is using induction motor in Model S, but when they launched Model 3, so they shifted to IPM CNRM motors. So what IPM CNRM motors is? It's a internal permanent magnet synchronous reluctance motor. So what happens in induction motor itself? The inside a commutator, inside a stator, or inside the rotor, they have inserted the permanent magnets in order to get a good output and a very efficient initial torque. So that's how they are shifting from induction motors to IPM CNRM motors. And like Tesla is very much pioneered in EV technology, so they have been doing a lot of research and development. And in this the latest Tesla Model 3, they have come up with this particular type of motors. So now we will see the different mountings of motors. Okay, how exactly they could be mounted on electric vehicles. So there could be two types: mounting the motor on chassis, as you can see here, in the conventional way, how the engine used to get mounted on chassis. So in that manner only we can also mount the electric motor. And another way could be to fix the motor inside the hub, inside the wheel hub itself. So there, these two could be the possible arrangements for that. And both of them have their different advantages and disadvantages specifically. So what may I know what you guys think, which one could be the beneficial, having inserting the motors inside the hub, or having it placed on the chassis? What could be one or two advantage points you can get from this? So let's first talk about the chassis mounted motors. Okay, so what will happen when you mount a motor on a chassis? It cannot be directly connected to the wheels. It definitely has to go through some shafts and transmission system which is present there. And if it's a front motor rear wheel drive, so definitely there will be a drive shaft. So in nutshell, there will be multiple mechanical components involved to deliver the power from motor to wheels. Okay, so when there are more mechanical components involved, definitely there will be more noise and losses and vibrations. So those things will come in picture. And what advantage wheel hub or hub wheel motors or in wheel motors will have is they will completely eliminate those linkages or mechanical components. There won't be any kind of gear or the differential and the drive shaft, those kind of things. So it will eliminate all those mechanical components and result in a very quiet, less noisy, and efficient propulsion or the efficient performance. So but what could be the disadvantages of having motor mounted inside the wheel. So let's have a look over that as well. So when we motor is mounted inside a wheel, it's very easy to install and replace, right? Because you can just remove the wheel from the body and get it repaired or replaced, whatever it's required. So that will be very easy. But when you have motor mounted on a chassis, you will have to go through various components in order to get it removed from the body. So this is the first advantage that in wheel motor has. Then there is a flexibility in mounting. Okay, so what happens when you have this chassis mounted motor, there will be you have to sync it with the mechanical linkages which are there. But in case of in wheel motor, there is no such requirement. You can directly put it into the wheels, so there is a flexibility of it. Okay, and it's very compact, right? Because it won't take much place to cover. It's directly seated inside the wheel, so there is no need to have additional this compartment. So this also give rises to one more advantage having in wheel motors. That could be the having more spacious vehicles, right? Because you don't have any underhood component as of motor or engine. The prime mover is itself inside the wheel, so that space you will get and you can utilize it for passenger sitting purpose or the luggage compartment. So that could be a one very good advantage of having in wheel motors. And as I mentioned, they are very quiet and efficient in performance, and they give very easy traction control. Okay, so traction control is a very big advantage of having in hub motors, because when you have one motor mounted on an axle, you are controlling the complete axle or the two wheels with the help of that particular motor. So it becomes difficult to control individual wheel speed and the torque. So when we go for torque vectoring thing and torque balancing in specific terms, so that becomes very much important, very much advantageous having in wheel motors. So those things are there. And as it has various advantages, definitely there will be some disadvantages as well. So what happens is when you fit the motor inside the wheel, the unsprung weight of the vehicle, it gets increased. So do you guys have idea what unsprung weight is, or how significant it is in terms of vehicle dynamics? So by term itself, you can understand what would it mean, unsprung. Hmm. Anyone? Okay, no worries. So there are two types of masses in vehicles when we talk in terms of vehicle dynamics. One is a sprung mass, and another one is a unsprung mass. So sprung mass is something which is above the spring, or which is above the suspension. Okay, so the body of the vehicle, then seats and chassis, tank, batteries. So all those will be the sprung mass. They are mounted over the suspension, and whatever comes after the suspension, that is called unsprung mass, and they are directly in contact with wheels, and whatever the loads will be there or the jerks will be there on the wheel, so they also will be faced by the other components which are there. So what exactly are the unsprung mass? So what comes after the suspension and between the road and suspension, how many components are there? Okay, so in unsprung mass, we can say the brakes. Okay, brake is somewhere inside the wheels, so that comes under the unsprung mass. And wheel itself is a unsprung mass. We cannot put the wheels before the suspension. So wheel, brakes. So these are the unsprung mass, and we are adding the motors to it, so it will definitely drastically increase the unsprung mass, which can affect the dynamics of the vehicle. So this is the disadvantage it comes with. And these motors are quite heavy in nature, and having it fitted inside the vehicle will definitely result in a heavy weight or the unsprung mass. So it might be difficult to control the vehicle or the turn the vehicle. So that challenge has to be tackled when one thinks to put the in wheel motors inside the vehicle. And another thing is they are exposed to environment. So as wheel is directly contact in road, so what happens, the dirt, water, mud, so all such things will definitely it will be exposed to, motor will be exposed to those things. And for that purpose we need to give the very high IP ratings to those particular motors in order to make them long life, or have the good life of those motors. Because when they are exposed to such harsh conditions, definitely their life will get reduced, and fatigue will be there on the components. So that is another disadvantage of having in wheel motors. And lastly, they are quite expensive, as they are very compact in nature and their windings has to be made very delicately. So this is why they are relatively quite expensive as compared to the chassis mounted motors. Okay, so moving ahead, do you guys know which truck is this? Do you have anyone has any idea? So surely this is not a Tesla Cybertruck, but it can be considered as its competitor kind of thing. Okay, so let me show you. So this is the Rivian R1T, and this is kind of world's fastest electric truck, or the truck specifically, if I say. So the specialty of this particular vehicle is that it has quad motor setup. So in each of the wheel, there is a motor mounted here. Okay, and all the four combined motors, they give 800 of horsepower to this giant vehicle. And it's like very awesome to ride when it comes to off-roading. It's a 4x4 truck, and it has, like, it can turn at its place itself, having turning all those four wheels in different directions. So that these many advantages having in wheel motors can bring to the electric vehicle. And the power that it delivers is massive, and the initial torque is quite high, as each of the wheel has its dedicated motor. And the traction control is like at different level in this particular truck. So this comes with very great advantages, but at the same time it's very costly, definitely. But this gives a very top notch technology to it. Okay, so this is one model, for example, that has in-wheel hub motors. And after that, let's have a look at these Formula students teams. So they have achieved 0 to 100 kilometer per hour in just 1.513 seconds. And what exactly made them achieve this speed possible is the motor, electric motor, because IC engines cannot give this much sudden acceleration in any circumstances, but electric motors are capable. And why is that? What exactly is the reason having this very quick acceleration thing? So can you guys name what exactly advantage of electric motor has resulted in having this quick acceleration? So there is a property of electric motor, okay, that it gives a torque, a maximum torque at its 0 rpm itself. And this is where electric motors are the, like, engine cannot come in comparison with electric motor at this particular part. Because engine cannot produce a very high torque at a very low rpm, but electric motors definitely they can. And these guys have put a motor. They built an electric vehicle having a specific motor, which because of which they achieved 0 to 100 kilometer in just 1.513 seconds. So you guys, if you are interested, you can go and research about what exactly which motor they used, and how they exactly controlled it, how they were able to achieve it. And the very interesting part is that the driver of this vehicle is a female teammate, their female teammate. So that is there, and they were like quite famous in the news when they built this particular record. And this is the fastest acceleration world record till yet. And this was possible because they used the electric motor. So definitely we are shifting towards the electrical era. Then electric motor is the only thing that drives the electric vehicle. So having doing a research on that and gathering very good knowledge of that, these particular technologies, what are new upcoming trends in electric motors, and which all companies are, what type of research and development they are doing, what all areas you can explore out of those particular research. So that thing, if you learn about it, will be great, and you sometimes you might break these records as well. Okay. So now we can get a review of what exactly we learned into this session. So firstly, we talked about what electric motors are, how they work, and we also saw different types of motors very quickly. Then we discussed different motors used in various two-wheelers application, four-wheeler applications, and after that, how the mounting of motors can give different results. That thing we saw. And what are the various advantages, disadvantages of having hub motors or in-wheel motors, that we had a looked upon. And lastly, we saw about Rivian R1T, that acceleration part, and the AWZ Formula student teams, how they built a world record of having acceleration from 0 to 100 kilometers per hour in just 1.513 seconds. And all this could be possible because they had gone through and did a research about electric motors, and they built that kind of motor and the transmission system to fit inside that vehicle. So definitely you guys can also learn these many things. And if you have good interest in learning this about electric vehicles and all such stuff, definitely Elite Techno Groups, we are providing you opportunity to explore more about electric vehicles. And as you all know that it's going to be, it's a turning point of automotive sector definitely. And upcoming 10 years there will be more electric vehicles on the road than the IC engine vehicles. So definitely there will be plenty of job opportunities out there who people who have good understanding and good knowledge about the electric vehicles and its components. So electric motor is one of them. Definitely batteries are there, power electronics are there. So you need to get familiar with these things. So being a mechanical guy, you might have understanding of how to design a vehicle, how to develop a CAD models. But in terms of designing electric motor, you also have to have understanding of different components of motors, its working, and like it. Electric vehicle is something which is multidisciplinary domain. No matter what background you come from, whether you are mechanical, electrical, you have to. So electrical guys, they need to have some or what some other understanding of vehicle working and traction, vehicle dynamics, and all such things. So these kind of things go hand in hand, and try to learn other domain knowledge as well. Okay. So hope you guys enjoyed the today's session, and you can visit Elite Techno Group's website to go through the courses. Let me just show you what exactly we have for you guys in when it comes to electric vehicles. So we are planning a whole specialization program, and we have specialization program for electric vehicle domain. Okay. So here you can see a electric vehicle, specialized in electric vehicle. So it will be a year-long program. When you are into your third year or final year of engineering, you can enroll, and by the completion of your engineering itself, uh, you will get good understanding of all the electric vehicle related technologies. So it covers all the development from from very basic to advanced level of knowledge in electric vehicles. So if no matter what background you come from, mechanical or electrical or electronics, if you are interested to learn about electric vehicles, you will be given complete knowledge from very basic to at a level that you will get a good job in the industry. Okay, so you will learn different batteries, design of batteries, analysis from electrical point of view, mechanical point of view, electric motors as well. You will see what different analysis are done on the motors and how they are very much important when it goes to sizing the motor. So these many things you will learn when you enroll in these programs. Okay, so in the chat box, the I will put a link to get some. You will get a discount when you go through these codes, and also try to fill up the form. The link I will be sharing in the sheet. Just give me 1 second. Okay. So here is a feedback form link I have put in the chat box. You can fill the feedback of this today's session, and if you have uh, other similar things you want to learn about electric vehicles, that also you can mention. We will try to set boot camps for that, and there is a code as well, promo code, so that you can, if when you go to our website to get these courses, you will get a discount. Okay. So if you have any question or discussion you want to do based on the today's session or the courses which we provide, so definitely you can ask. Yes, if there is anything you guys please mention, or if there is nothing to discuss upon, so we can conclude today's session. Okay. Sure, I guess there are no more questions. So thank you very much everyone for attending this session, and I hope you learned something out of it. And if you have more eager to learn, definitely go and like there are plenty of sources available to learn such technologies. So and Elite Techno Groups is one of them, and we are providing very quality content, as well as you will have a good hands-on projects which are developed from the industry experts. So go to the website, and you can also follow up our website to register for upcoming webinars. We in every week we come up with such webinars for you guys. Okay, Chandragupt, you can put your email ID. I will share it with our team so that you can get the certificates for that. Okay. Thank you very much, Omkar. Okay, yes. I will forward it with our team, and we'll try to deliver your certificate as soon as possible. Thank you very much. Okay, guys, keep learning, keep exploring. Bye.